Hello, Magnus Solberg behind the microphone here again. Tonight we're going to talk about a very interesting pilot trial where we removed color and odor/smell with nanofiltration. In the middle picture here you see a cut from an article that was written about the pilot project at the time. The pilot trial was going to look if it was possible to replace a rather complex old conventional treatment plant, including pulverized activated carbon, flocculation, sedimentation, sand filtration. If nanofiltration could replace this, the typical parameters of the pilot trial for the lake was about 7, turbidity ranging from 3 to 7, color about 50 to 60, which is kind of yellowish, and COD, which is a measure of organic content related to color, of course, about 18 to 14 milligrams per liter, and dissolved organic is about 8 to 9 milligrams per liter. Temperature varying over the pilot trials between 3 degrees to 18 degrees. Last but not least, a very high silt density index, or quote-unquote clogging index for membranes. And this can be expected, of course. With the membrane process, we use 2 steps. Microstrainer with automatic flushing, step 1. Membrane unit with nanofiltration membranes, step 2. Now, the pilot trials was run for about 12 months with a 24-hour operation per day. Process parameters in regard to this, the pressure 8 bars at 18 degrees Celsius. Of course, if the water was colder, the pressure will go up. Drinking water production was 85% of the raw water coming into the plant, and the reject or concentrate was, of course, 15%. Flushing of membranes with water was done every 24 hours. Cleaning of membranes, including chemicals, had to be done every second day. Now, for the result from the plant, I've actually taken from the article a cutout. And this is in Sweden, but you have here membrane nanofiltration, that was Swedish and English. Here you have turbidity less than 0.05, color not detectable, COD less than 1 in the water from the membranes. Now, conventional treatment will give you a turbidity about 0.05 or below that, and the color about 5, and the COD 1 to 2. This was achieved in the existing plant, but of course with several steps and a lot of chemical handling. To make it short and summarize, 2 treatment steps could replace the several treatment steps in the old plant, and also heavily reducing the chemical use in the plant, which is a big bonus, of course. Also, better water produced, which probably means less disinfection for the distribution networks, also a big plus. However, energy for the membrane process was a question, the cost for the energy. Also, frequent cleaning of the membranes to handle that, which also include some chemical handling. Also, the question of how to dispose the concentrates, was it going back to the lake or to the sewage treatment plant? Again, classical question you need to answer before you decide on a membrane plant. Handling of wash water from the cleaning, usually you neutralize it, but it goes to the sewage treatment plant, which should be okay. But again, you need to check before you make a decision on if you want to build a membrane plant. Now, if you want to read more, you can have a look at this article from Desalination. And it's old, but I would say the things we did in '96 are as valid as we speak today as they were when we did them. These are 2 pictures that are from a holiday me and my wife did in the western parts of Sweden. I like the pictures very much. That's why I put them up. Maybe you like them too. But anyway, just one thing. Thank you, and remember, water really rocks. Take good care, and bye-bye.